Thank you everyone for joining us in this session on batteries for the maritime sector. This is the second of our series. So last time we looked at batteries for defense. Today we're looking at batteries for maritime, and in a month's time we'll be looking at batteries for rail. I'm Nikoleta Piperidou from the Clean Energy and Infrastructure team. With me today, a lovely panel. So with us, Mark Wray, also from the Clean Energy and Infrastructure team. Mark is leading on the Decarbonising Ports and Harbours Innovation Network. You'll hear from him in just a couple of minutes. Also with us, Matthew Moss, our maritime expert from our transport team. Hi, Matthew. With us today also Ross Wombwell, Head of Technical Services at British Marine. Good morning, Ross. With us also today, David Tyler, Commercial Director of Artemis Technologies. Good morning, David.
Good morning.
And last but not least, Tanya Ferry, Head of Environment at the Port of London Authority. Good morning, Tanya. Just a couple of introductory slides before we get on with today's agenda. In terms of practical aspects, as you'll see, there is both a Q&A box and a chat box. Please use the chat box for networking. We're keen to hear from you. Tell us from where you're joining us. What are your interests in the space? What are you looking for from the session? So we look forward to hearing from each and everyone from you. Please use the Q&A box for specific questions for the speakers. That will make it easier for us to identify the questions. And the webinar will be recorded and you'll be receiving all the material shortly after. So just on today's agenda, short introduction from myself. I'll be followed by my colleague Mark. We'll move on into a high-level overview of the decarbonisation of the maritime sector. Further on, we'll hear more about specifically batteries and their role in the space. And lastly, we'll hear how batteries can also decarbonise the ports and harbours space. So a nice mix of presentations, and will be followed by a Q&A session chaired by Matt. So this webinar today is delivered by the Cross-Sector Battery Systems Innovation Network in collaboration with the Decarbonising Ports and Harbours Innovation Network. Our innovation networks are part of a wider portfolio of projects. You can see here some of our projects, very wide range. So the mission of the Cross-Sector Battery Systems Innovation Network is primarily to open new markets for the battery industry, promote innovation in batteries, and help decarbonize a wide range of end users. We've started from a small and diverse group of our founding members, and we've now moved on to over 350 members that we're trying to put together in a landscape map, which will be available shortly in our new online hub. So as part of our plans for Q1, we will be launching the online hub. Hopefully in 2-3 weeks time. We will then work to improve the hub based on your feedback, and the main aspect of it will be a place for you to go and find any information of relevance related to batteries, funding opportunities, news, and be able to connect with other players. And just a quick reminder, if any one of you is interested, so this is a program for UK SMEs somewhere around in the battery supply chain. We are offering this investment readiness program, and the deadline is today. It's a short application, so you still have a chance to apply, and there are few spaces available. So if this is of interest, please do apply. That is all from me. Thank you very much. And I will now pass on to my colleague, Mark. Mark, over to you.
So, good morning, everybody. So, in the next few minutes, I'll present on the inspiration for us to establish our innovation network around decarbonising ports and harbours. As Nikoleta said, my name is Mark Wray, and I work for the Clean Energy and Infrastructure team with Nikoleta at the KTN. And I'm also the innovation network lead, working closely with my colleagues in the transport team, so from Matthew Moss, who you'll hear from in the Q&A session, who's our maritime lead, and also Simon Buckley, who works on our low emission mobility work. As Nikoleta said, this was one of a handful of innovation networks launched last year. So one of the greatest challenges we face is how to decarbonise our industries and societies at large. For decades, we've built up our systems dependent on fossil fuels to energise them. The maritime environment is a complex place with many systems converging in singular geographic locations. They're filled with substantive assets, burning large quantities of predominantly diesel fuel to mobilise them. Much of the equipment, vehicles and vessels is transitory and operates on a global platform. Decarbonising the marine environment is a Herculean task and will require international cooperation with informed and determined local action. This is partly why the greenhouse gas emission reduction targets at an international scale are for 50% reduction. But here in the UK, we are committed to showing global leadership and have a 100% reduction target. Ports and harbours were a particular challenge with complex ownership. With complex ownership patterns for not only the place, but also the equipment and assets within it. These assets have long lifespans covering several decades and are significant capital investments. They have specific functions to perform and often used for extensive run periods, with some running 24 hours per day. Current commercially available low zero emission equipment solutions do not readily lend themselves to the duty required, and we do not currently have the energy network to support them. Therefore, we need to quickly reach consensus about how we'll transition to net zero carbon in ports and harbours. So the aim of our network was to catalyse pockets of cross-sector activity and establish a community, a common goal to enable the coordination of effort in addressing the challenge of reducing emissions associated with port landside activity, whilst also providing the infrastructure to service a growing demand for non-fossil fuel derived energy for the vessels and visitors. Our activity is guided by an advisory group, which has grown slightly from when this slide was put together. Our advisory group consists of challenge owners, so those organisations who own and in some case operate the ports, along with solution providers. Sorry about that. I'm going to have to, sorry, it's suddenly stopped working on the PowerPoint presentation. I will carry on with the script. Let's get this going again. Hold on, bear with me, please.
Mark, I think Matt might have a copy of your slides if you would like him to share them, putting Matt on the spot there.
No, it should be, you can see that?
Yeah, that's working perfectly.
I've got it back up and running now.
Yeah, thank you.
Okay. Right, sorry about that. So challenge owners, so organisations who own and in some case operate their ports. Solution providers, those who operate the ports or provide solutions to the challenge owners through their supply chains. And influencers, those who create or lobby on policy, taxation, regulation and insurance. So our group is chaired by Dr. Jo North, who's at the Port of Tyne. She's the Director of Technology Transformation. And she's deputised by Commodore Jeremy Bailey from the Royal Navy, who operates out of HMNB Portsmouth. We've got a highly engaged group and it's a pleasure to work with them. Since our launch last year, we're growing our community and promoting our planned activity. And if you want to find out more about us, our planned work and how you can connect, then please visit our webpage. There you can watch the video of the launch event with our socially distanced panel discussing why this is important and what we're going to do about it. You can also read about our planned activity and then open up to registration, sign up and contribute to our events and activities. So our work plan for 2021 breaks down into three main areas of activity. We have a series of working groups to inform workshops and the subsequent reports, maps and outputs that come from them. Our workshops will be we are currently generating a landscape map similar to the one that Nikoleta just showed us for the batteries, and that will map out where the challenges are faced and who has the capabilities to solve them. We'll also be developing a roadmap of solutions development. So what solutions are we going to need to decarbonise over the next 10 to 15 years, and our map of how we're going to deliver those. And we'll also be associated with that building an investment plan to present to the private and public sector on the levels of funding and finance will be required by the industry to deliver a net zero carbon solution. We also have running alongside this an innovation exchange platform, which will be addressing the here and now challenges. We're going to have 3 new challenges go onto our portal this week, which you can access via our webpage. The challenges are sponsored by a selection of the port owners and operators who seek approaches to mitigating stranded diesel assets, so where they're looking to keep the full life use of the asset over its lifetime, whilst the emission reduction targets start to impact on operations. So this might include things such as replacing mobility components, augmenting them, or adding efficiency improvements. We'll also be looking at an exchange program to look at stimulating shore power solutions. The market for shore power is nascent but growing and currently tends to favour larger vessels. This call is looking to stimulate smaller installations and looking at efficient means to connect vessels and manage electricity systems in ports. So hopefully this just sets the scene a bit on why we are interested in this subject and an outline of what we are going to do as a team. Thank you for listening.
Thank you, Mark. That was fantastic. Rose, I will now like to pass on to you.
Great, thank you. Good morning, everyone, and thanks for inviting me along today. So my name's Ross Wombwell. I'm Head of Technical Services at British Marine, and I'm going to be looking at the recreational and touch upon the small commercial sectors. Just a quick note on who we are. We're a membership organisation with the leisure, super yacht and small commercial marine industry. We've been around quite a long time. We've got about 1,500 members, like I said, from super yacht all the way through the supply chain. That covers about 75% of the turnover of the industry. So emissions. Well, to be honest, in the marine industry, clean air hasn't been something we've thought about too much until the last few years, and the focus really came on us as part of the clean air strategy released in 2019, and the attempt or the objective for zero net emissions by 2050. This was followed up by the Clean Maritime Plan, which really gave us some very particular objectives, in that by 2025, only 4 years away now, it's expected that all vessels operating in UK waters are maximising use of efficient energy efficiency options. All new vessels being ordered for use in the UK waters are being designed with zero emission propulsion capability. That's a tricky one. And finally, zero emission commercial vessels are in operation in UK waters. So this was released in late 2019. Now, as an industry, the recreational side, we have got a fairly large new build market, as you can see there. You know, production is about 1.2 billion. A large quantity of export, over 900 million in export, and we import a small amount. So we have quite a big sector. But it's not only the new build that we have to look at. Unfortunately, boats last a long time, or fortunately, boats last a long time. The average life of a vehicle on the road is, as they say, about 7.8 to 10 years. You know, with a 2030 ban on petrol and diesel, which is where the government seems to be going, the fundamental change will therefore be within 10 years. You know, we're going to have a completely different automotive industry within 10 years. But the average age of boats are a lot older. They're between 40 and 50 years. And some of our inland fleet have no end of life. The zero net emissions levels by 2050 means all boats since 2000 and some from the early 20th century may all need retrofitting. So we're not just looking at new build, we're also going to have to look at the retrofitting of the existing fleet. And this is the recreational side. You know, we have a boat park of probably just over 500,000 boats in the country, of which 100,000 motorboats, just over 200,000 sailboats, 170,000 outboard engines on boats, and then a small number of other products such as PWCs. So we have a large existing boat park which is going to need to be retrofitted as well. As we're going through this process, we are looking at all the alternatives. So alternative propulsion for us, not just electric. We're also looking at transitional through alternative fuels, GTL, bio, etc. We're looking at traditional hybrid systems, diesel or petrol generated, pure electric. You know, there are pure electric solutions out there, but also alternative hybrids, you know, fuel cells and LPG. Current electric only systems at the moment for the marine are suffering the same problems as the automotive sector, which is range and charging facilities. And in the marine industry, we have high energy usage. Just pulled up a few examples of the current market, just so you can see what's out there at the moment. So this is a recreational craft around 35 foot. On a normal combustion engine, it'll have a range of 200 to 300 nautical miles, and probably kind of twin 200, 250 horsepower engines, maybe up to 300 horsepower. With an electric replacement, you can see that you may get 185 nautical miles, but that's running at 5 knots, significantly below the normal operating speed of these vessels, which is 25 to 30. You also, when you push it, your range is going to drop down to 20 nautical miles. So this is the risk we have at the moment, is we don't have the energy storage capacity at the moment to enable pure electric, which is why we're having to look at these alternatives. I have another example here. You know, again, this type of vessel would have a normal combustion engine range of 200 to 300 nautical miles, probably running at around 30 odd knots. However, you know, with pure electric, we're looking at a cruising speed of 9 knots and a range of 42 to 80, depending on your pack. When you go up to the maximum speed on electric of 15 knots, which is half the non-electric speed, then the range drops all the way down to 20 to 40 nautical miles, depending on your battery packs. Finally, this is one of the bigger boats. This is kind of a traditional size vessel of what we have at the moment, which is around 50 foot. Again, 200 to 300 nautical miles, top speed of up to 30 knots, and that's with 2 500 horsepower engines. But then when we get to electric, you're looking at 20 nautical miles at 4 knots, the maximum speed of 6.5. So you can see we have some significant challenges when we are looking at our market and how the products that we manufacture operate. And these are the challenges that we're going to have to find solutions to. The current pressure we're feeling within the industry is definitely consumer-led, and they are now asking for products we have yet to build. You know, every consumer is asking our boat builders, what's the hybrid package, what's the pure electric package, and we have yet to get to, in the majority, have those packages. Regulation is yet to be confirmed on this for us, but the long-term strategy is being developed by government for the transition to zero net over the next 30 years. You know, we are in discussions with the government at the moment on what the objective of the 2025 zero emission capability actually means. Capability is a lovely word. We're certainly going to be looking at what that actually means, and discussing with the government how, as an industry, we can try and achieve it. The market is small in number, but high cost in price. So, you know, there is a market, and as I said, it is consumer led. You know, we are hearing that the smaller pure electric, such electric outboards, etc., they're selling out. We can't get enough of them at the moment. So there is a market for it, and we need the technology to meet the customer and the consumer expectations. The industry as a whole, lots of SME OEMs, very, very hard to get into. We are a cottage industry, except for a few big companies within the industry. And when I say big, I'm only talking about an 80 million turnover plus. So we are a small cottage industry. It's hard to enter. It's hard to get connections, and that's what we're here to support and to help. And that's why I'm here today. For those who may want to find out a little bit more information, we do run some stats. So we have small commercial marine sector facts and figures, looking at the industry, where the focus of the industry is. Be that boom farm support, be that passenger vessel. We're seeing a lot of move in passenger vessels at the moment, especially, as you can imagine, on the Thames. I know Tanya's going to be talking about that a little bit later. And again, recreational stats globally. I think the one thing I want to probably end with is what we're seeing is regulation changing quicker than the technology is able to achieve it. So we've certainly been hit by a couple of new emissions rules in the last 6 months or so, where we don't have engines to meet those objectives. So part of the work we're doing is working with government to make sure that the rules that are set are achievable by industry, and that we have a clear path to the long-term objective in 2050. And hopefully some of you will be able to help us get there. So that's it from me. Thank you very much.
Thank you very much, Ross. That was excellent. I've already started seeing questions in the Q&A box. If you have any more questions for Ross or any of our other speakers, please do pop them in the Q&A box. We will be having a Q&A session at the end. I would like now to welcome David Tyler of Artemis. David, over to you.
Good morning, everyone. Hopefully you can see that screen. So yes, I'm a commercial director with Artemis Technologies. We're a spin-off from the Swedish America's Cup challenger Artemis Racing. Historically, we provided design and engineering services to both high-performance racing teams, but also commercial clients, and also been developing some unique hardware solutions for our clients, including maritime simulators and other control hardware pieces. Our big mission when we started the company was really to see how the technology that we'd developed through the America's Cup, namely hydrofoiling and wing sail technology, could support the decarbonisation of maritime. I just want to talk a little bit about what we're doing and why we're very interested in development of battery technology within maritime itself. Over the last couple of years, we've been developing our Artemis e-foiler electric propulsion system, which is a combination of technologies from the America's Cup, hydrofoils, aerospace, control technology, and high power density engines developed through motorsport. This hydrofoiling propulsion system is for high-speed vessels, and it significantly reduces the operational costs through fuel savings. And we're hoping to launch this technology later this year. The first boat that will launch with this technology will be a 11-meter workboat. It's great to see Ross talking about the other technologies and what power solutions have been delivered by Torqeedo and those players in the market. But with our system, we're aiming for a cruise speed of 25 knots on this 10-ton vessel, top speed of over 30 knots, and a range of 60 nautical miles at that 25-knot cruising speed. So we really think that this technology is going to be quite transformative, and at the moment it will be for the next few years we believe it will be the only really commercially viable solution for high-speed maritime transport. Following the workboat, we will be launching a high-speed ferry in 2023. We will also operate that ferry in a pilot scheme between Bangor and Belfast in Northern Ireland. Nominally, it's going to be 35 meters, over 90 tons, with a cruising speed of 35 knots and a top speed of over 40 knots. So really targeting inner city transport, commuter transport services. At a 35 knot cruising speed, we're hoping to be able to deliver 80 nautical miles with pure battery energy storage systems. And this technology, compared to sort of current fossil fuel high-speed ferries, high-speed catamarans that you might see going to Isle of Wight or in San Francisco, this technology can deliver 90% fuel savings through both drag reduction and efficiencies of the electric drivetrain. So batteries in maritime today. There are a number of vessels operating already. Over the last few years, it's been significantly increasing. Big drivers by the IMO to hit emission targets. I just think generally, we as a society globally, we understand that climate change is happening. We need to do something. And with the IMO lead, the maritime sector is really now waking up and needs to act, and it needs to act fast. Batteries are one of the few available options for ships to completely operate without emissions, but at the moment only really for very short distances. Whereas automotive is able to switch predominantly to EV battery for emissions targets. As Ross mentioned, mixture solutions are necessary for boats due to the sheer scale of the power requirements and the size of the vessels that we're talking about. Big change really has been driven by advancements in lithium-ion battery technology from automotive. And while maritime battery systems are different from those used in cars, they require different battery management systems, require higher powered energy. The battery cells are essentially the same, but there are challenges in maritime. If there are fires or issues in an EV car, it's very easy to jump out and get out. Obviously more challenges when you're on a boat out on water, so there are significant certification and regulatory requirements as well for maritime that it has to overcome. So which vessels are using batteries? At the moment, it's most common in car and passenger ferries, significantly so. There's almost over 400 battery projects at the moment. The leisure market as well, and yachts, comes in second under other activities. And I'm also seeing a lot of battery technology coming into the offshore supply ships and cruise ships. It works with passenger ferries at the moment because of potential shorter trips, but also the standardized duty cycle. You have a timetable with an opportunity to charge in between trips. And with the leisure boats, generally they're personally owned and typically traveling short distances as well. We're starting to see a lot more hybrid projects, particularly tugboats and also offshore supply vessels. There's big potential there for both retrofit and for new build battery technology. And then on the larger ships, we're also seeing batteries being used to optimize the power management, both in terms of propulsion and auxiliary power use to save fuel and reduce maintenance costs as well. So where are these ships operating today? Northern Europe is certainly leading the way, particularly in Norway. This is the Future of the Fjords, which is a pure electric ferry that's been operating there. The picture below is the Damen ferry bus, water bus, which is a number of those being operated already, pure electric, zero emissions. And then there's also a lot happening in Southeast Asia as well. And this is a ferry that's been developed by Absolute Energy, who are the automotive manufacturer, the Tesla of Southeast Asia. And there's also a few projects starting to happen in the US as well on the West Coast. But certainly at the moment, Northern Europe is leading the way in this space. And just building on what Ross said earlier as well, there are a number of pure electric programs out there, particularly in the passenger ferries and in the leisure market. But the majority, over 75 of the entire fleet, are using hybrid systems. Very important. It's, we do need to decarbonise, but the numbers do need to add up. It needs to make commercial sense. And very similar to automotive, for this technology, there is an upfront capital cost. And also the thing to consider is the additional cost of charging infrastructure required, which can be challenging in maritime to deliver that. However, when these systems are fitted, on the right route, the right vessel, then they can have significant operational benefits. This is a ferry operating in Norway between Lavik and Uppendal. Since 2015, it saved 60% on average on fuel costs and then making significant CO2 emission savings as well. And I think it goes back to the point that Ross has made, where there's, vessels need to travel relatively slower speeds, then there is big potential to decarbonise. Once you start moving to higher speed vessels, that's when drag significantly increases. You need more batteries, therefore your weight increases, and it really snowballs out of control. And that's where our foiling technology, we hope, can really break down that wall. And mentioned this earlier, but yeah, there is obviously the majority of the battery technology has been incorporated into new build vessels. But there is also big potential for retrofit, and in the offshore supply market, there's a number of projects already happening. So there's already a solid business case there. What does the future look like? The use of batteries is certainly going to continue to rise. New manufacturing facilities, bringing the cost down of batteries, different chemistries like solid state coming online as well. Within 5 to 10 years, with solid state batteries, we could see 3 times the energy power density and also 3 times the speed of charging, which can have not just an impact on maritime, but also on other mobility sectors too. And there's a big opportunity for other enabling technologies. So, you know, our e-foiling technology or hydrogen fuel cell technology, etc., and other fuels to play a part in decarbonisation of maritime. But whatever those solutions are, batteries are going to be a standard component and play a very important role. Thank you.
Many thanks, David. Again, another excellent presentation. I will now like to welcome Tanya Ferry of the Port of London Authority. Over to you, Tanya.
Good morning. Thank you very much. And hopefully you can see my slides. And thank you for the opportunity to talk about the challenges in the Port of London. Now, I'm going to cover these 3 points here. In terms of a port, we are perhaps a little bit more unique in terms of the challenges, but hopefully we'll be able to illustrate some of the larger issues that ports face going forward in terms of space and power demands for vessels in decarbonisation pathway. I'm going to use our own case study as an example. We've just announced we're going to be net zero by 2040. That's going to be quite a challenge as an authority with a number of vessels that have been used on the river for a long period of time. I'm going to talk in principles about the work we've been doing as across the port, which is a 95-mile river from Teddington right out to the sea, and hopefully in doing so illustrate some of the challenges that the port sector is facing that Mark and his team are helping us to reach decarbonisation. Hopefully my slide will go forward. Yeah, okay, good. So in terms of the PLA, we are a very small organisation in relative terms, but as you can see from our baseline, vessels emissions are a lion's share of our challenge, and in very short term we intend to reduce that to 65% emissions, but we still have quite a long way to go to completely eliminate all of the other subsidiary emissions and challenges. We are going to be switching all of our vessels to biodiesel this year, and the last one being switched in early 2022. But that only gets us part of the way. So we have to consider the vehicles that we use to take staff up and down the river, where perhaps vessel access isn't appropriate. And then we have our entire fleet of vessels to decarbonise by 2040. In terms of our operational sites, we've done some work across the river which I will refer to as an inland roadmap, which is a decarbonisation roadmap for vessels, which included the PLA's own fleet. In order to decarbonise, our sites are going to require, just for the individual vessels, between 700 and 6,000 kilowatts to be provided to those sites. That's per vessel. And what we believe is technically feasible at this precise moment in time is slightly different, as you can see. So there's a challenge in how that might happen. But one thing to note is the vessel's roadmap does include battery hybrid, as well as fuel cells. So there's a potential mix in the river and on our sites in terms of both battery, hydrogen or hydrogen carriers, and for a short term, the biofuel itself as a mix on those sites, and keeping them safe is going to be part of that challenge. It's also worth noting we already have a hybrid pilot cutter, which we had to do some significant infrastructure changes to the operational site in order to charge the vessel while it was alongside. The traditional shore power approach for our smaller vessels was not suitable for the amount of charge that vessel needed when it was at berth. So in terms of the port supports several thousand jobs, and it has a significant GVA in terms of particularly the southeast contribution. So it's quite important that it continues to run in an appropriate way to continue a just transition in terms of keeping jobs and the economy running. At the moment, a lot of the supply has a fuel component, so fuel for transport on the roads, aviation, as well as the maritime sector. But also you'll see containers and a number of other cargoes and construction materials coming through the port. In terms of how we get it into the capital and how we move people, there's 9 million passengers not traditionally carried in the Thames. Obviously that has changed over the last 18 months, but that is the normal volume of passengers you would see moving on the river. And 5 million tonnes of cargo, traditionally construction materials. Now that those vessels, which are slightly larger than the PLA's vessels, require the carriage of up to 4,000, almost 5,000 kilowatt hours in terms of continuing their current operation. So the roadmap we undertook looked at how the continued operation would survive in terms of the fuel would be required. And the next challenge for us as a port authority is to work out where that power is going to be provided from. Larger vessels, deeper vessels are quite a challenge in an inland waterway. In terms of shipping, so international shipping isn't quite at the moment in the net zero, although some operators are committing to that for 2050. The IMO has not yet set that standard. But in terms of power, just for shore power, as Mark's mentioned already, it can need up to 6 megawatts, and some of those stays are over 72 hours. So that needs to be sustained for some significant amounts of time. Now the PLA itself has run a green tariff, so requires discount for better performance from international vessels through the Environmental Ship Index. I have put links on the slides so that when they're produced as PDF, you should be able to access these references. And we also, in December, launched an inland version of that for the Thames operators. So as they continue to improve their performance, they can be recognised and provided with discounts by various incentive providers in terms of the solution. The Climate Change Committee 6 carbon budgets talks about over 70% reduction by 2035, and we're talking about some of these transitions or trials in terms of feasibility not occurring until 2025, 27, or maybe even later. So reduction on 70% when a fleet has one vessel trialled in that sort of period is going to be quite some challenge. In terms of multimodal freight, use of the waterway is already a low carbon transit route. It outstrips even rail at times, depending on the volume that is carried. But it also has the opportunity to potentially, in large urban areas like London, eliminate some of the last mile freight in terms of the Amazons and deliveries that might be the last vehicles to retain in urban areas. But as I said earlier, the challenge is the heavier and the wider that these vessels are in order to accommodate their new fuel type could mean that they actually need to change their journeys to be shorter or not be able to carry as much and therefore not be as efficient. We have to find that power in a particularly for London, in an area that has a grid system that has to decarbonise the rest of the transport network. And in terms of the ports where the grid perhaps doesn't quite meet, as mentioned earlier by Mark, we also have to decarbonise the port equipment, which, as Port of Tyne have demonstrated, it is possible, but there are challenges to that. And the image there is the London Gateway electric straddle carrier. So there are solutions out there, but they are quite challenging in terms of how you might power that alongside the vessels that are coming to it. So in terms of the infrastructure, do we do that first, or do we plan for that and leave those assets there and hope that they are the ones that are required? Do we future-proof? As Ross has already mentioned, there is an element of vessels being designed for, but is infrastructure being designed for that future-proofing? What the power demands might be? How do we scale up when more vessels come online? Are the solutions going to be chicken or egg? Do we put the vessels on site on the basis of the feasibility that we have in our inland roadmap? It says feasibility for infrastructure is 2027, but in some cases the trials for the vessels could happen as early as 2022. That doesn't sound like it's going to be a viable trial if you haven't got the infrastructure even feasible. So we are doing a piece of work this year to look at where that power is across the 95 miles, how the mix of power and fuel is required over the next 25 years to help plan and transition that future proofing for both infrastructure and for vessels, to give the inland operators some certainty about their investment. We recognise batteries are a part of that solution, but as we found with all of the other types of technologies we've talked about in terms of decarbonisation, we're not seeing a silver bullet, but we are seeing silver buckshot. We are looking at research at the moment, but that is only taking us so far. We can share information. We'll, a lot of it is already on our website, but we want to see that technology in use. We want to see it working on the Thames. There is an element that a lot of the operators see the Thames as a challenging environment for these new technologies, but there are synergies in terms of provision back to a capital city that is relying on its river to provide it with cargo and trade. As I've said already, the time is now, and we're working with KTN on a number of the innovation exchanges Mark's mentioned earlier, and there'll be others coming forward specifically around the Thames as well. But we recognise that working together is going to be the key for our success. So in terms of safety, that is first. So mixing fuels is going to be a key part of our concern as an authority, but we are searching for innovation. We want to see zero emission berthing as standard on the river in the next 5 years. And we are looking at a net zero strategy for the Thames as part of the Thames vision. A just transition does need to be happening. We do need to see the training and the jobs there for those to retain their current economy, and the operators have the ability to continue to grow, perhaps in a different manner, and the port must continue to serve the southeast. So that's my slides in a nutshell. Hopefully that's answered some questions, perhaps given some more challenges, but please do get in touch with us through Mark and the team as to coming up with solutions. We're very interested in what might be possible in the future.
Many thanks, Tanya. That was excellent. Lovely presentations this morning, and loads of questions coming in. So I've seen that some of our speakers have tried already to answer some of the questions as they came in, but we still have loads and loads. So I would like to now welcome my colleague Matthew Moss, our maritime expert, who will be able to amalgamate some of these questions and make sense of the dialogue and the flow. Matt, over to you.
Thanks very much, Nikoleta. But before we go on to the Q&A, I thought as you're all here, let's find out what support there is available for the maritime sector in terms of funding, because as we know, none of this innovation can happen without a bit of incentive to get you on the way. So without further ado, I think for the maritime sector, there hasn't been a place where you can go as a one-stop shop in terms of funding, and hosted by Maritime UK, the umbrella organisation for the maritime sector, in collaboration with KTN on the Maritime UK website, we've put together a funding and support portal. Now these slides are going to be circulated afterwards, so you are able to click on that link, but here's just a little overview of what's available at the moment, and we see a number of different funding and support mechanisms for businesses engaged in the maritime sector to help you take your innovation forward. So please do come and check that out. And if you were to Google Maritime UK funding opportunities, I'm sure you'll be able to find this in exactly the same way. But that's a really good one-stop shop. Of course, the KTN has many different funding opportunities and general opportunities on their website, but they're not all maritime specific. So it may be a little harder for you to delve into them and find those out. But of course, we always encourage you to talk to us, because we have such a wide range of sector expertise here, and we all talk to each other. We're very friendly, and we can help you sort of signpost to the best possible funding or support that is applicable to you. So come and have a chat there. Going into a little bit more specifics of what funding is available at the moment, I can hear a collective groan when I put smart grants up there, but they are always there and always available for you to bid into for a chance to drive your innovation forward. They run quarterly. The sort of time period is generally quite long. The next one runs until the 26th of May. There's normally quite a large pot of money available, in this case 25 million, and depending on the length of your project, you can apply for certain amounts of money. They are highly competitive as they are open scope, so just be aware when you're applying that you need to be the best amongst the best in order to succeed in an Innovate UK Smart Grant. There's another funding call by Mari UK, who are funded by Department for Transport. This one has a very deadline that's very, very close. So it's the 15th of February. So if you are interested in this one, I encourage you to get your act together very quickly. So Mari UK is, they call themselves an innovation vehicle for industry and academia. So they're really trying to target bringing those sort of research projects out of universities up the TRL scales to around TRL 7. Their current funding call, the Smart Maritime Land Operations call, is about that interface between the shore side and the vessel side, and how we can encourage the movement of goods and the throughput through the ports very efficiently. But there is also an emphasis on clean growth and sustainable way of doing so. So battery technologies may have some role to play in one of these projects, but obviously you'd need to partner up there to maybe some sort of logistics partner to help you put a entire proposal together. I can quite happily connect anyone interested into Mari UK to help them with that matchmaking process as well, and understand a little bit more about the scope, but time is of the essence, very much so with this call. I've just highlighted a few sort of regional business supports that are available. So if you're blessed enough to live in sort of Cornwall or Devon, there's or even the Solent area, there is regional innovation support available to you through Marine Eye, the MBTC and Low Carbon Solent. And also if you're up in Scotland, there's the Census network, which is on sort of census. So if you're thinking about autonomous shipping as well, there's perhaps opportunities there. But I really encourage you, this is just to highlight that depending where you are based in the UK, reach out to those people in your area, sort of your growth hubs, your local LEPs, even sort of KTN, we can direct you in terms of regional support. There is, albeit perhaps small grant funding available from these organizations to help you sort of kickstart that idea. So, and if you want connections into any of these organizations, please again, reach out to us. And finally, some sort of more bigger aspirational sort of funding schemes that are on the horizon, but not live yet. So the first being the Driving the Electric Revolution Challenge. And there is actually a preview of this competition that KTN are hosting tomorrow. So please check out the KTN website in order to sort of sign up for a sneak peek of what that scope is going to entail. But Driving the Electric Revolution is all about sort of the PEMD, so that's power, electronics, motor and drivetrain, sort of the supply chain side of the industry. So if you're thinking of batteries, you've got to think of your supply chain as well. Where's all that coming from? This is sort of the funding competition for you. It's set to be released, as all these ones are here, in March of this year, but we've caveated that is due depending on ministerial announcements. That's not confirmed yet, that's an expected. And with the transport decarbonisation plan coming in the spring, these announcements may happen concurrently or separately. I'll move on to the last one. So the 20 million for the freight trials to support hydrogen and zero emission HGVs. Now, that is perhaps not maritime directly related, but it can happen in the context of a port where you have lots of vehicles, perhaps niche vehicles that are not usually seen on the road, and they need to also swap over to lower carbon or even zero carbon energy vectors. So there's going to be, again in March, asterisk there, that a competition is going to be live. And this is really looking for kind of these advanced feasibility studies to put a big project plan in subsequent years together, because with this year being a one-year spending review, obviously not anticipating a lot is going to be delivered. So it's about laying a foundation for subsequent spending review years where it's a multiple year budget. So there'll be a bigger budget hopefully available next year. But if you bid into this funding, you've got a better shot, you've got your foundation laid, so you're going with a good shout when there's more money available. And similarly with the Clean Maritime Demonstrator Programme, It's about these advanced feasibility studies or really shovel-ready demonstrator projects that can be done within a year time frame. Because if the money's not spent within the year, it is simply lost. So we're either looking to, again, lay the foundations or do something that's kind of quick and ready to go right now. And battery technology are definitely part of the scope for that Clean Maritime Demonstrator Plan. It's fully focused on how can we transition the sector towards net zero in line with the, I guess, the 10-point plan from that Boris Johnson announced, the overall net zero emissions by 2050, and also the IMO's GHG reduction by 50% by 2050 as well. So that is a very quick blast through the funding schemes available at the moment for the maritime sector. So now let's head over to the Q&A. And I have done my amalgamating in the background, Nikoleta, you'll be happy to hear. So let's start off with, I'll open it up to the entire panel. We'll start off with some quite broad questions, and anyone who wants to jump in, please feel free to do so. So I think the first question I'm going to ask and pose to the panel is, what are the main challenges of deploying battery technology in the maritime sector, and how is that different from automotive, where we've seen obviously a lot of battery technology applied already? So I
know I can jump in quickly. I mean, you know, with the small commercial and recreational sector, I suppose one of the big focuses is safety. You know, unlike the automotive, you can't pull over and get out when you're at sea. So the level of safety required, systematic safety required within the marine industry is definitely different.
Thank you very much, Ross. Does either David or Tanya want to jump in?
Yeah, I think also just in terms of the you know, vessels operating at sea being hit by waves, it's a very different duty cycle compared to a car, which is effectively riding on a flat road. So there are challenges there, and also seawater doesn't react with a lot of materials, so there's challenges there. And you know, there are a couple there, but the safety is the obvious one, particularly, you know, the requirement to be able to nullify that issue if there's a fire on board or something like that, compared to automotive. It's a much bigger challenge.
I would just add to David's point about the tides. You know, the speed over water is very different in terms of the forces against momentum in one direction, and a distance of a mile in one direction could use a disproportionately amount of the battery to go back the other direction. So I think it is making that a viable calculation, that you have the sort of 70% or, you know, operation and 30% safety, and actually that then creates the volumes that you then need, that limits the design that Ross has demonstrated in terms of size and speed that the vessels are able to take. And 4 or 5 knots is the flow of the tide in the Thames because of the funnel it's in. So those vessels would probably maybe maintain station, to use the maritime term, but they wouldn't be going anywhere until the tide turns, and then possibly not be able to control where they are because they've used entire battery power in that process. But I think designing to that is possible. It's just that working together that needs to happen in order that those problems can be unpicked and established in a more constructive manner.
Definitely, I think working together is a really key point there, not just for the sort of vessel operators themselves, but the ports such as yourself. It is, we don't want to end up with that chicken and egg situation that you described earlier. So moving on to the next question, we've talked about the actual battery themselves, but what supplementary technology is needed to support the sort of deployment of batteries in a maritime environment? So we're thinking here on sort of thermal management, maybe data to feed a battery management system that can, I guess, maximize the range and energy efficiency of the battery, and any sort of shoreside connections infrastructure that could go alongside that. I may have answered some of the points that you're going to raise already, but please feel free to elaborate on those. That's open to the entire panel.
Perhaps I can go first then, I guess, for the shore powered side, or the shore side of things. We definitely, the smart tech and sort of some sort of way of communicating with the power demand of the vessel as a sort of a connected network would be a really key part to maximise the energy efficiency and meeting the power demands. It's almost, in terms of smart automatic technologies, in terms of making sure the power's in the right places, or the vessel is told where to go to charge, in terms of if you override it in a different way in terms of safety.
Thank you. David or Ross?
Yeah, I think charging is a big one, and I think it will work with a ferry where you can have a hub, which is there to charge that ferry, and can be designed to meet those requirements specifically. But I think it's very challenging where you have lots of different types of vessels coming in to charge at the same place. And with a car, you might have a 60 kilowatt hour battery, but even with our work boat, we're talking about a 250 kilowatt hour battery. So to charge that using a standard automotive charger can take a long time. So actually maritime needs much higher charging infrastructure than automotive does. So that's a challenge in itself, given that we're generally piggybacking off the technology developed through automotive.
Yeah, I would add to David's comments, and I think one of the things certainly for us is location. When we're looking at marinas, when we're looking at ports, they're generally at the end of the line. Very often not around other high energy uses, such as population centres and industry centres. So for us, getting the energy to the areas where people will be plugging in is going to be a big challenge.
Yeah, definitely. We've all got to, again, it's that working together with the shore side and the vessel side to make sure that we come up with a collective solution that can drive us forward. And especially in an international market as well. The UK is not alone in having ships. We're not unique in that aspect. So any solution that we do deploy here in the UK has got to be compatible internationally. Otherwise, we don't want a Betamax situation here. And yes, I know what Betamax is, but I'm sad to say that I'm too young to actually remember them. We've got an interesting question here about, I guess, is batteries the only technology to drive us forward towards net zero? I know the net zero targets are legally binding, but in a question from Ralph here, on the last webinar, Batteries for Defence, we saw that in the next 10 to 15 years, there's only going to be around a 10% improvement in battery technologies. So how does batteries fit into the overall scheme towards sort of this decarbonisation and achieving net zero? Is it the only solution, or does it have like a piece of the puzzle to play?
Well, I go back to my silver buckshot analogy. I will admit I actually stole that from a hydrogen expert, so that kind of tells you where it came from. We don't see it as the only solution. We see it as part of the mix, and I do recognise that some technologies aren't going to move fast enough to meet some of those deadlines, whereas others may do. And I think there's an element of competition between the two. Each has its challenge in terms of a ship operation or an inland vessel operation. Batteries are heavier in terms of where the technology is at the moment, so that creates a depth issue in a shallow inland operation. Hydrogen, it's 6-7 times the volume of the fuel that they might need to carry if they were to carry as much as they do now. So therefore, you then are, that's where the chicken and egg is. The infrastructure versus the carriage, but it does change the design of the vessel. And I think it's the recognition that there is a third part to this. Life is not going to be exactly the same as it is now, and some of these things will need to change to make sure that decarbonisation is part of that, in terms of that solution. And the long journeys that some of the inland operators are making now may not be possible between fueling may not be possible anymore because of the type of fuel they're using.
Yeah, I mean, I'd certainly add to that. I mean, energy density is the issue, and I think there is a lack of awareness maybe about the quantity that's necessary within the marine industry. I mean, just one example, that I can give is a 60-70 foot pleasure yacht, which has twin, 2,500 horsepower engines, a 20,000 litre diesel tank, and uses 600 litres an hour per engine. These are large numbers, and energy density at the moment, and that's what we need to be looking to achieve, is a replacement technology with the sort of energy density that we're able to utilize, or we're just going to have to change what we do.
Thank you very much, Ross and Tanya, for your answers. And we are, sadly, I'm afraid, run out of time for questions. If you did ask a question and it didn't get answered live, don't worry, we will be capturing all the questions raised in the Q&A, and we can put together perhaps an FAQ to circulate after the event. But I just want to hand back over to Nikoleta and thank you all for the so many questions that have been put in the Q&A box.
Thank you very much, Matt, and thank you very much all for joining us. Thank you again to all our lovely speakers. Thank you to you, Matt and Mark and Poonam. Thank you all. And as Matt said, we will follow up with material from today. If you have any specific questions, we'll try and get back to you on these. We're always here and always happy to help. Thank you all.